So number one is the y-axis. The dependent variable is always on the y-axis. By way of review, which one is the y-axis?
Vertical.
Vertical. We had different arms facing different directions in a moment of confusion. So the y-axis is going vertical. The independent variable is the x-axis. So that is going the other way. For purposes of future communication, this right here is called the origin. Each of these zones is called a quadrant, with quadrant 1 being
Right.
top right, and quadrant 2 living
To the left.
to its left. And work our way through to quadrants 3 and 4. 3 through 5, this first picture right here is called inverse. You don't have to do an equation for it today, but you will on the test. In the practice test, you can see it's the last question. Can anybody tell me an equation of how the inverse equation looks? That's a good thing I'm here. It's going to be y equals that k over x. We have an x on the bottom, that makes it be an inverse graph. In this type of thing, if x goes up, it makes the y go down. And if the x went down, the y goes up. For example, there's an inverse variation, let's say, to the time you spend playing video games compared to your physics grade, I would think. That if your video game time goes up, your physics grade would tend to go down, and vice versa. Those would work somewhat inversely, maybe not a guarantee on that, but that would have an inverse sort of feel to you. This one is called linear. It's called linear because it is a line. So the equation for linear, y equals mx plus b. The line, there's no really preset kind of relationship like this necessarily, because lines can have a positive slope or a negative slope. So lines can kind of take you either direction. There's not quite the same relationship. What's special about this one? Starts at the origin. So while you could argue for linear, because it is a line, your better thing here is direct variation. Equation,
Y equals mx.
y equals mx, and really the letter doesn't matter. Mx is probably better, I think that's what our book did, but if you did some other letter, it's not super important. In this one, if x goes up, it makes y go up. And if x went down, y goes down. That would be maybe like the time you spent reading your physics book compared to your physics grade. If one of those goes up, you would expect the other one to go up. But life doesn't have a lot of guarantees, but you would expect that to trend that way. Then I have one more I threw in my notes that I think makes the practice test. Does the practice test say the name 4? That last question on the sheet says 4. Yeah, okay. So there's another one called a direct square variation. And that would be something like y equals ax squared. People with experience with square graphs, how do they graph? Use. We're only worried about quadrant 1 graphs for the most part in here. What's special about quadrant 1 that makes it more appealing than the other quadrants?
All positives.
All positives. So we tend to stick more to positives, so we're more living in quadrant 1. But when you get your quiz back, or if you want to help your neighbor out, you can fill in those sorts of details, because some of that will show up on a quiz in a bit. While we're on that topic, let me just do a sketch graph here. In the homework tonight, they are going to ask you to graph a little bit of stuff. So they might label you a table with like T stands for what from our cheat sheet the other day? Time. S stood for
Second.
disagree. It could be as a unit if I said like 40s, that is 40 seconds. But if I do a heading on a table with an S, that isn't. That's a different thing. If I did an equation with an S, that's a different thing.
Distance?
That is distance, also known as displacement in our world. So in the homework a little bit, they're going to give you a table now and again, and they're going to ask you to make a graph. As long as they stuck to all positives, you don't need a full coordinate system. You only need a quadrant 1. But you aren't going to have an x-axis. What kind of axis do we have? A t-axis. T standing for time. So we'd want to label time on an axis. We don't have a y-axis. We'd have a distance axis. Because usually you're used to x over here, y over there. They're going to use other words instead of x's and y's. In the x direction, how would I ideally count? Like I got my marks over there. If I want to put some numbers on my x-axis, what numbers would you expect? 1, 2, 3, 4. I would agree. Would you on the y-axis expect me to count 1, 2, 3, 4 up to 160? I would not think so. I would count the way the table's counting. The table's counting by 40s. So I'd go 40, 80, 120, 160. Do I have to count that way on the y? No, I could count by 1s to 160. Or I could have counted by 10s or by 20s or whatever I chose to count by, and it would be fine. Then what would I do about this if I were asked to make a graph? Origin, 0, 0. What would I do about this? Over 1 up 40. Over 2 up 80. Then, and then I play connected dots. So they'll ask you to make a sketch graph every now and again. And then they will probably follow up with what type of problem did they just do. In this case, they did direct variation, because it looks like that. But it might be other ones. There's going to be some of that in the homework. Question about any of that new kind of stuff? Okay, then through the rest of the quiz, for the scientific method, we have experiment, analysis, conclusion, and testing. If they messed up the order, we'll take a point away today on that. Convenient is powers of 10. The world system is SI. The 3 units are kilograms, meters, and seconds. Physics is the science that examines the relationships of matter and energy. Kinematics have some sort of noun like study of or science of, but the key word is motion. Mechanics, science with forces and energy. If they only said one of those 2 words, I could go half, but it's both, forces and energy. Accuracy is the degree of agreement between a measured and a true value. The degree of agreement between a measured and a true value. Not necessarily something I want you to say on the quiz, but accuracy is like the thing that's your fault as a human. Either you were accurate or you messed up. Precision is the instrument's exactness. It's what your instrument is able to do. Like I have a postage scale at home. It can only weigh things up to 3 pounds. So if I try to weigh something that's 4 pounds, that's not my problem. That's the instrument's problem. It only can do 3 pounds. So the instrument's exactness, that's the precision. Adding or subtracting, we are going to round before. If they just only said before, that's only half a point. The extra thing is to round them all to the least precise place. You could say that different ways, I suppose, but you want to round beforehand is half, use the least precise place, or the least exact place, or something like that is the other half. Multiply, divide, you're rounding after. And you need a word like fewest in there. You're going to use the fewest digits from the problem. The fewest significant digits, fewest significant figures from the problem. You'll hear me switch back and forth. Significant digits, significant figures. It's the same thing. Some books say one, some books say the other. I don't even remember what our book says because they're interchangeable words. The list of significant digits is anything other than 0. Zeros that have the bars on top of them wearing like bar hats. Zeros at the right end of decimals, so you have to be careful about that we're headed like all the way to the right end of decimals. And then zeros, you could say confined zeros if you like, or zeros that are in between other significant digits. Those are all ways you could explain that one. And I think we can cut that video, and that's